So here we have a kinetic energy problem, and let's just get straight into it. So it says during your winter break, which is actually right now because it's December 28th, you enter a dog sled race across a frozen lake. And if you're a UHS kid, you know we don't have this here. Anyways, this is a race where each sled is pulled by a person, not by dogs. To get started, you pull the sled, total mass 80 kilograms, with a force of 180 newtons at 40 degrees above the horizontal. Find A, the work you do, and B, the final speed of the sled after it moves 5 meters, assuming that it starts from rest and there is no friction. Alright, so that's a lot of information, and that's a really long paragraph. So, I mean, like, we don't really need the first part here. That's just giving us background info. But, let's start with part A. Actually, let's start with drawing a diagram of what is happening. So, we have our 80 kilogram sled right here. Alright, and it's being pulled by a force of 180 newtons, 40 degrees from the horizontal. And it also moves 5 meters at some point. So, let's get started with A. We only really have two equations for work, and then in this case, if we look at what we're given, then we have to use this equation. So force times displacement times cosine of theta, because all of this is given to us. And let's just plug in our values, which will get us 689.4 joules. And first part is done. Now, the second part gets a little bit trickier. We could theoretically do this with kinematics, but we've learned how to use energy. So remember, work equals change in energy. And if work equals change in energy, and we look at what energy is all about, so we have K plus gravitational potential energy and spring potential energy. Well, there is no spring, so we can automatically assume that's zero. And we're not really dealing with gravitational potential energy here because, the object is just staying where it is. So we can also rule that out. And that leaves us with kinetic energy only. So this is why we've called this the kinetic energy problem. And this should be actually the change of kinetic energy because, change of energy. I just want to write that. But if it's change of kinetic energy, then it should be 1/2 m final velocity squared minus 1/2 m initial velocity squared. And since, 1/2 m is constant in this case. So we already know that initial velocity is 0 because we can imply it from the problem. So we can already rule that out, which makes our equation work equals 1/2 m vf squared. And we calculated work, so let's just plug everything we know in. And if we solve for that, we are going to get 4.15 meters over seconds. And there you go. Now you know how to solve energy problems. So just remember this process right here, and you're pretty much all set. Anyway, see you guys in the next example then.